Hello everyone, welcome back to the new video. So in this video we are going to design these whiteboard cards and we will also give the functionality so we can make multiple whiteboards. If you are finding the content valuable, please drop a like on the videos. It really helps me stay motivated to keep bringing you more. So let's get started. And we will also use Kotlin datetime library. So what you need is you need to go to this libs.version file and I already have added this dependency. You can also add from the GitHub repository. And here is the version and in the module level file and here also you need to add these two lines. Next thing, we will also use an image. So you need to paste one image in this drawable package with the name image canvas, this image. And after adding those two things, you need to rebuild your project so we can access that image. Now let's close all this. And first thing we need to add one data class with the name whiteboard in our domain model. So here let's create one data class with the name whiteboard. And in this whiteboard we are going to save id and this will be of type long and by default we will keep this null value. So the room library will generate this id and we also need the name of type string and last edited. And here this will be of type local date from this Kotlin X datetime. And in the last we will keep the canvas color. This will be of type color, compose UI graphic. Next we need to design a single card and we will use that single card in the lazy grid. And for that go to this presentation dashboard and here create one package with the name component. And here we will keep components related to this dashboard screen. And first component will be the whiteboard item card. And we need to use this card from this material 3 library and this card already has this column scope. So whatever content we will keep, it will be placed on the vertical axis. And first thing we will use an image and this image will be the image we just pasted. Resource dot drawable dot image canvas and content description will be simply whiteboard. And after this let's use a row layout and here we need two things. First this text for the name and to this card we will pass the whiteboard and the name of that whiteboard we will use here. Let's also put this max line to 2 and after this an icon button. And after this row let's use text composable and here the text will be the date. Now let's create a preview function so we can preview this whiteboard card. So that preview function we will create in the Android main. And here let's create one file with the name previews and we will keep all the previews here in this file. And we need to annotate this with preview. This first one, compose UI tooling preview. We don't need modifier and call our whiteboard item card here. And we need to pass the whiteboard And here let's use a dummy whiteboard with name. And here we need to pass the local date for this last edited, and we can use our local date class from this Kotlin datetime, and we need to pass these year, month, and year. Let's use 24 and month 12 and date 23. And let's see the preview. It is not showing the preview, so let me rebuild the project. And Gradle has been synced, so let me show the preview. And here is our drawing card. It is not looking that great, but let's modify it. Go back to our whiteboard item card and make few changes. First thing, this modifier let's attach to this card. And next thing, we need to give some padding from the top. So here on this image, use the modifier with padding to top 8 dp, and also align it to center. And next thing, this row here, use the vertical alignment, and vertically they need to be center. And in this name text, we need to use this modifier with the name weight. So what this weight modifier will do, it will take the maximum available space with this 1f weight, and also give padding from the start 8 dp, and copy this and use in this last one. And here we don't need the weight modifier, but we need the padding from the start and the bottom. And now let's see the preview again. Right now it is showing this card little bit wider, but we will use this card in that grid, so it will take only the available space. And here we can also see how all these layouts has been placed. And first we have this image, and here we have given padding from the top. And next, this row layout, here this text is taking the maximum available space, and then we have this icon, and in the last we have this text, and here we have given the padding from the start and the bottom. And next thing, we need few things. Here I have written this date hard coded, but we will take the date from the whiteboard. So what we need is, let's delete it and use this whiteboard dot last edited. But this last edited value will be of type local date. So we need to convert this local date into a string. So here we need to create an extension function so we can format this local date into string. So in our common main package, in the presentation package, and here util package, let's create one file with the name extension functions. And this extension function will be on this local date, and the name will be this format date, and it will return this string. And here formatting the date is quite simple. We need to take this local date, and then we need to use this format function which comes from this Kotlin X datetime. And in this format function, we need to provide the formatter. So formatter we will again use from this local date, and in this lambda, first we will use this day of month, and then we need a character with slash, and after this we need month number, and again we need a character, and then we need a year. And this is how it will be formatted. and use this function on our last edited value dot format date, and we can see the preview. And here is the date. But if I pass the date something different like 25 and this one to 2 and this one 19, and let's see the preview again. And here is the date it has formatted. Now next thing, we need to add a menu icon. So whenever user click on this menu icon, so a menu bar should open. And for that menu we already have code. So let's go to this whiteboard and this component and the top bar and scroll down, and here we have this more option menu. So let's cut all this code and go to the dashboard and component and paste it here. So a new file has been created, and import all the required values. And first thing, let's rename this function to by pressing Shift F6 whiteboard card more option menu, and we also need to rename the file. And here we will be having this drop down menu, and right now we have these four items, but we need only two items, one for the rename and another one for the delete. So let's remove these two, and here use this rename. Let's also rename this to on rename click. And optimize the imports and use our more options menu in our whiteboard card. And we need that more options menu to be open when user will click on this icon button. So let's put both these things in a box, and that menu will be placed accordingly. Let's remove this private modifier, and now we can use here. And this on rename and on delete, we will let's copy these parameters from here, and we will provide these two parameters wherever we will use this card, and attach these two here. And for this is expanded, let's create a state locally. And this value, let's attach it here, and when user will dismiss this menu, then we will make this value to false. And when user will click on this icon, then we will make this value true. And this is how it will open and close. And we need to see the preview, but our preview will give error. So let's provide those two parameters as blank parentheses and open this preview window. Click on this render issue and build and refresh. And here is the preview, there is no change, but let's open this interactive mode and click on this icon, and here is the menu bar. If I click on any of this item, it will disappear. So it is working fine. Let's stop this interactive mode. And next thing, we need to use this card in our dashboard screen. So for that, go to the dashboard screen. And right now we have this box layout as the parent layout, and next this top bar and this floating action button. And here let's use a column layout, and this column needs to be fill max size. So copy this modifier and use it here. And in this column, first we will keep this top bar, and we can remove this align modifier because that top bar will be placed on the top. And after this we will use this lazy vertical grid, and in this lazy vertical grid we need to provide first this modifier with fill max size, and next this columns, and we need the columns adaptive. So we have this grid cells, the place dot, and we can provide these three values, and in this fixed whatever value we will provide, then our card will be of that same size, but we need the adaptive. And here we just need to provide the minimum size, and we need the minimum size of our card to be 150 dp. And you can also see the documentation of this adaptive by hovering the mouse on this adaptive. And you can see here, if we provide 20 dp as the minimum size, so there will be as many columns as possible, and every column will be at least 20 dp. So here they have also shown if the screen size is 88 dp, then it will be shared to 4 columns with 22 dp. And next we need to provide this content padding. So with this content padding we can provide padding values all around the content. So we need padding of 16 dp all around, and we need have this vertical arrangement and this horizontal arrangement. And with the help of these two parameters we need to provide the padding in between of those cards horizontally and vertically. So for that we have this arrangement dot space by, and we can simply use 10 dp and copy this, and horizontally also 10 dp. And to see the preview, let's just use this items block with count, and let's use 50 counts. And to see, let's copy the code from that preview file, this code, use it here. And now we can run our app and see how this whiteboard card is looking. So go to this terminal dot slash /gradlew run. And here we have the desktop app. These are the dummy whiteboard cards, and we can see 50 cards. And if I resize it, and here we can see they are placing adaptive. So let's minimize this and this one also. And here instead of this dummy values, we will create a state class with the name whiteboard state. And here we will keep the whiteboards of type list of whiteboard, and by default let's use this empty list. For now we will keep only these whiteboards in this state class, and this state class we will provide to our screen. And also we will manage that on card click, and we will pass the ID of that whiteboard whenever user will click the card with the type of long. And here, instead of these 50 items count, let's use our list state.whiteboards, and we need to import the different items function. We will get the whiteboard, and this whiteboard we will provide to this card. Next, we need to use this modifier with clickable, and we need to pass the ID, but let's use the null check with let and call our on card click. So whenever user will click on this card, we will pass the whiteboard ID. And this dashboard screen we are using in the nav graph. So press Ctrl B and go to this nav graph. And first thing we need to provide the state. For now, just use this whiteboard state default values. And next this on card click. And on this on card click, again we need to use this nav controller with navigate function. And we will navigate to this whiteboard screen, but this time we have the whiteboard ID. So we can go to that whiteboard screen from this dashboard screen in two ways, either by clicking on this card or on that floating action button. So when user will click on that fab, so then we need to pass this null value and we will create a new whiteboard. But if user will click on this card already created whiteboard, then we need to pass the whiteboard ID of that particular card. So we can fetch all the paths related to that particular whiteboard. So that's why we are passing this whiteboard ID. And this whiteboard ID we will get not in that whiteboard screen, but in that whiteboard view model. So let's go to the whiteboard view model. And here we have this class with the name saved state handle. So this class also keeps the navigation arguments, and we need to access that nav argument with the name whiteboard ID. Let's use this private val and whiteboard ID, and we have this saved state handle class. And this new navigation library provide us this function to route. So we just need to provide the route which have this argument. So this whiteboard screen route has this argument, and we can access by placing dot this whiteboard ID. And we can see on this whiteboard ID that this whiteboard ID will be nullable long type. So this can be either null or the ID. So this is how we pass the argument to the next screen and get those argument in the view model. Now let's close all these files. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore, and more. Check out the course in the description and take your skills to the next level. See you there. Now next thing we need to add the code related to that room library. So we can save all the data related to this whiteboard in a separate table. So first thing, let's go to the data package, and in the local package here we have this entity. So create one more entity with the name whiteboard entity. And first thing we need to annotate this with entity annotation. So room should know that this data class will be used as the entity, and the fields will be exactly same we have in the whiteboard data model. Let's copy these values and paste here and annotate this ID as the primary key. So room will use this ID as the primary key and make this auto generate to true. So this ID will be auto generated. And let's also define the table name. So the table name will be, let's use constant file. Let's also rename this to simply path table name. Copy this constant and use it here and import it. So this data class will act as the entity. Now here few things we need to update. First, this canvas color, right now it is of type color, but that table cannot save this color value, and we need to save this as the integer value. And again for this last edited entry, this cannot be saved as the local date. So we need to save this as the string value. So for that we need to create the converter function to tell the room how it needs to convert this local date. So for that, in our converter package, create one class with the name local date converter. And here we need to create two functions from local date. Here we will pass the local date and this function will return us the string value. And next function we will be having this to local date. So this from this function we will convert our string value to the local date, and this function will return us the local date. So to convert to and from this local date, it is quite simple. From local date, here to convert into a string, we have this function with the name format. So this function can convert that local date into a string, but we need to pass the format in which we need to convert. We will provide that, but here again to convert that string to the local date, we have a function on this local date with the name parse, and we need to provide the date, the string date we need to convert, and the format. So for both the functions, the format will be same, and that format let's define here with the private val sortable date format. And we will use this local date dot format, and here again we need to provide the format with the year, months and date. And here we will first use this year and then these characters with slash and then month number, again this character and then this day of month, and we will use that format here. And we need to annotate both these functions as the type converter, this singular one. So here why I am using this particular format, but when I need to convert that local date into a string for that whiteboard card, I use the different format in that presentation package, this extension function here. I am using this different format. So this format will be used to display that local date into that card. But here I am using this particular format because this format will be more appropriate for sorting purpose to that SQLite. Because when we will get the whiteboards, then we need to sort all those whiteboards by date. So here this particular format will be more appropriate. Next, we need to write functions to insert and get the data from the room database. So we will write those functions in a 𝗣. So here in a 𝗣 package, let's create one interface with the name whiteboard 𝗣. And we need to annotate this with 𝗣. So room should know that this will be the interface where it needs to use the functions. And first I will write two functions with this suspend keyword. The reason of writing these two separate functions instead of writing one single function is because we need to get the ID of the inserted whiteboard. So when we will use this insert annotation, this will return us the ID of that row which this function has inserted this whiteboard. But when we will use this update annotation for update function, this will not return us the ID of that whiteboard. Rather, this update annotation returns the integer value of the number of rows it has affected this update operation. So this is the reason of writing these two functions. And next, let's write two functions for getting the whiteboard. First will be this get all whiteboard. And this function will return us the flow of list of whiteboard entity. And we need to write the query because there is no particular annotation for getting all these values. So query will be quite simple. We need to select everything from whiteboard table, and here we need to get all those whiteboards with this order by last edited entry, and this will be the descending order because the latest date whiteboard should come first. And next, let's write the function for getting the whiteboard by ID and make this suspend function, and this will return us the whiteboard entity, and this can be null. And the query will be select everything from whiteboard table where id will be equal to the id we will pass. So these will be four functions for this whiteboard DAO. Now next thing, we need to register all these things in our app database class. First thing, we need to add the entity, this whiteboard entity. And we also need to update the version because we are changing the database. And in this type converters, let's also add our local date converter. And we have one more DAO. So this will be the code related to that local database. So let's close all these files. And next thing, we need to create an interface. So with the help of that interface, we will interact from the code within the presentation package. So in our domain package, in the repository package, let's create one more repository with the name whiteboard repository. This will be of type interface. And we need to define three functions. First one will be this get all whiteboards. And here we need to use the whiteboard model class we defined in this domain model, and we need to define a single function for that insert and update functionality. Now next thing, let's write the implementation of this whiteboard repository in our data package and this repository whiteboard repository implementation, and this will be of type whiteboard repository. Press Ctrl I and implement all these functions. Here we will pass the object of that whiteboard DAO through the coin library, and with the help of that whiteboard DAO we can attach this get all whiteboard function. But here we have one issue. So this DAO function will return us the whiteboard entity, but we need the whiteboard. So again we need to create mapper functions that will map the whiteboard entity into and from whiteboard. So we are keeping all those mapper function here in this mapper package, whiteboard mapper. and first function will be on this whiteboard, and the name will be to whiteboard entity, and this will return us the whiteboard entity. So we just need to attach all these values to their respective values. All these values will be same, only this color value we need to change. So in our entity we are saving this color value as the integer type. So use this to argb function and copy this function, and this time we need the function on this whiteboard entity, and this function will convert from whiteboard entity to whiteboard, and everything will be same, only we need to change this canvas color, and we need the color value. So we can pass our canvas color integer value to this color class. Let's create one more function that will convert the whole list of whiteboard entity to whiteboard list, and we will take this list of whiteboard entity and we will map each entity to the whiteboard. So this will be the function, and use this function here with this map it dot to whiteboard list, and this get whiteboard by id will also be quite simple with this whiteboard DAO get whiteboard by id, and we will pass the id and put a null check and convert this to whiteboard. So here again we need to make this whiteboard as the nullable, put a question mark on this and also in our interface, and we need to make this function as suspend, and same with this. So here we need to put a if block. If whiteboard.id is null, it means we are inserting the whiteboard. So we need to call this whiteboard dot insert whiteboard with this whiteboard to whiteboard entity. If the ID is not null, it means we already have whiteboard. So this time we need to use the update whiteboard function, but this update whiteboard function will not return us the ID, and we already have the IDs. We can just pass that particular ID. So this will be the implementation of our whiteboard repository. Now only thing we have left to code is the to our view models. So let's minimize this and close these two files. Now next thing, let's go to our presentation package and the whiteboard package. Here go to the whiteboard view model. And first thing here, let's get the whiteboard repository with this private val whiteboard repository. And first function I will write to get the whiteboard by ID. So for that we will use this whiteboard ID which we are getting from the previous screen. Let's use this init block. So the code within this init block will be triggered as soon as this whiteboard view model class will be created. Whenever we enter this whiteboard screen, so we need to take this whiteboard ID and put a null check with this let block. And if we have ID, then we need to call our get whiteboard by ID function, and we will pass this ID. But we don't have any function, so let's press alt enter and create this function. So this function will be quite simple. First thing, let's rename this parameter to whiteboard id, and here we need to use this view model scope because we are in the view model, and in this scope we need to call our whiteboard repository and then get whiteboard by id, and we can pass our whiteboard id, and we will get the whiteboard through this function, and this whiteboard will be used to update the state, and we need to update two values. So first let's add two more values in our whiteboard state. So let's go to our data class. Here create few more states. First one will be this whiteboard name, and this will be of type string, and by default we will keep this untitled. And next thing, this canvas color, and this will be of type color, and by default we will keep this white color, color dot white. And go back to our view model. First let's put a null check. If this whiteboard is not null, then we will update our state with this update function, and we need to update two values, this whiteboard name to the whiteboard name whatever we are getting through that whiteboard function, and this canvas color also. So this will be our get whiteboard by id function. So let's cut this function from here, and we will use this function after this on event function here. And next let's create one more function with the name upsert whiteboard. Again we need to use this viewModelScope.launch, and we need to call our whiteboard repository dot upsert whiteboard, and we need to pass the whiteboard to this function. So let's create a whiteboard. First thing, we need the name. So name we can simply get from our state, whatever name we have. If we don't have any name, then the default untitled will be saved. And we need to use this last edit date, and this canvas color. Again, this canvas color can be taken from the state, and the id. And the id we will get from the whiteboard id we have in the top, and we can pass this whiteboard to this function. Now we need to pass this last edit date. So we need to get the today value. So let's use our Kotlin date text time. We have this class clock from this Kotlin x date time and system dot today in. So this will give us the date of today, and time zone we can get time zone dot current system default, and we can pass this today value, and this function will return us the new id. So here if we are using this upsert whiteboard function for updating the whiteboard, then this function will return us this same whiteboard id we are passing. But if this function we are using for inserting whiteboard, then this whiteboard id we have in the top will be null, and here we are passing this null value. So that insert function will be called. So that insert function will give us the new id after inserting this whiteboard. So that new id we will save in a new value here, and for that new value let's use mutable state flow. Updated whiteboard id mutable state flow, and by default we will keep this whiteboard id. And after inserting the whiteboard, when we get the new id, then we will use that new id to update this updated whiteboard value, and this function will be called on this start drawing event. So here whenever we will draw the first path, then we need to call this upsert whiteboard function. So here let's put a flag with the name is first path. So whenever our view model will be created, this is first path value will be true. So on start drawing the first path, we will use if block. If it is first path, then we need to call our upsert whiteboard function and make this is first path value to false. So this upsert whiteboard function will not be called on the subsequent paths. And if user has opened an already created whiteboard, then when user will create the first path, then again this upsert whiteboard function will be called, and in this function we will update the date on which user has inserted the new path in the already created whiteboard. So in this way we can also keep the last edited value. And this absurd whiteboard function will also need to call whenever we will update this canvas color and this name. But these two functionality we will provide in the future videos. So for now we will call this absurd whiteboard function only on this on start drawing event. Now one last function we also need to provide. Here we are getting all the paths, but we only need to get those paths which have this whiteboard ID. So first thing what we need is in our path entity we also need to save one more value with the name whiteboard ID. So with every path we also need to save the whiteboard ID so we can differentiate between the paths to which path relates to which whiteboard. And next go to our path DAO and rename this function to get paths for whiteboard. And we also need to update this query. So we need to select everything from path table, but only where this whiteboard ID will be equal to that ID we will provide to this function. So this will be our updated function. Now go to our path repository implementation and let's also update these path repository function. First go to the interface and update this function get or get path for whiteboard, and we will provide the whiteboard ID. And in our implementation just pass the whiteboard ID whatever we are getting from the repository. And let's also update the name of this function. Let's press Ctrl B. And here first we need to add the whiteboard ID to our domain model also. And in our path mapper, just provide these two values and rename this function to draw path list. And just provide this like this. And now we can close all these files. We are getting some errors. Here we are getting these paths, but we will get these paths differently. So let's remove from here, and we have only single value. So let's also remove this combine function and use simply state. And for that paths, let's create one function with the name observe paths and create a new function and put this function after this on event function. Again we need to use this view model scope dot launch, and we need to use this updated whiteboard ID. So whenever this updated whiteboard ID will be changed, so we also need to call that get paths function again with the new whiteboard ID. So for that we will use this flat map latest. So this function will help us in calling that function path repository dot get path for whiteboard with the new ID if we have, and this id can be null, so in that case let's use just -1, and we will collect these paths with this collect latest function. Here we just need to update the states with the new paths, and this flat map latest function is experimental, so let's opt in this, and we need to use this id. and we are calling this function inside our init block. So as soon as our whiteboard will be created, we need to call this function, and we have one error in our update continuing offset. So we also need to pass the whiteboard ID to the pass, and let's use our updated whiteboard ID and get the value and put a null check. So we will get ID. If this updated whiteboard ID is not null, then we need to use our state.update function, and here use this it.copy, and we need to update this current path, and this current path will be this, and this updated path can be null, so wrap this inside the let block. And this is how we will save the whiteboard ID also with each pass. Now next thing, in our dashboard package, let's create a view model for this dashboard, and this view model will be of type view model, and we will pass the object of repository from outside with the help of that coin library. And here we just need to get the whiteboards. So let's first create state of type mutable state flow, and by default we will keep our dashboard state class. This needs to be dashboard state, so rename this to dashboard state, and create a public state value, and we will use this combine function, and we need to combine our local state with this repository dot get all whiteboards, and we will get our state and these whiteboards, and we will use our state to update these whiteboards and convert this flow into a state flow with the help of this state in function. Scope will be view model because we are in the view model, and starting strategy will be sharing started dot while subscribed. So this will be active for at least 5 seconds, and initially we will keep our default values of this dashboard state, and let's pass these state in our screen, and that screen we are using in our nav graph. So let's go to the navigation package and this nav graph, and here we have this dashboard screen. First let's get the view model of this coin view model, and view model we have this dashboard view model, and next this state by view model dot state dot collect as state with life cycle, and instead of this default values, let's use our state. So this is all the code. One last thing, we need to specify how the coin will need to create all these objects we are passing with the help of that constructor. So for that we have di package, and here let's go to the shared module, and we need to first duplicate this path DAO, and we need the whiteboard DAO, and next object is view model. So view model will be dashboard view model, and put these two colons, and again for this repository whiteboard repository implementation, put these two columns, and we need to bind this to whiteboard repository. So this was all for the coin. Now we need to run our app and hope everything works fine. So first let's run our desktop app. And here we have our app. So let's create a new whiteboard and go to the home, and we have a new whiteboard with the today's date. And if I update this whiteboard, and let's check it again, and here we have the updated whiteboard. And same, let's again create a new whiteboard, and here we have the new whiteboard. So things are working as expected. Now let's run our Android app, and here we have the Android app. So let's again create a new whiteboard, and go to home, and here we have a new entry, and go back again to the home screen, and we have these two whiteboards. And let me create one more whiteboard with some shapes. And here we have the whiteboard. So what I want to show you is how this is looking in our database. So go to this app inspection, and let's wait. And here we have the whiteboard database, but right now it is showing the close. So let's do the usual thing, close the app, and here we have the database offline. And we have three tables, one for this room master table, but these two tables, path table and this whiteboard table, are these tables which we defined. So let's go to this path table, and here we can see multiple entries, and we also have whiteboard IDs with each pass. Here we can see, and also this is how the paths are saving and these drawing tools. Now let me open the whiteboard table, and these three, right now we have these three whiteboards, and we have some default names, and we have these date as the string value like this, and we also have these canvas colors. For now we have just saved the default color. So this was all for this video. We have successfully added this multiple whiteboards functionality, and in the next video we will give the functionality to that laser pen tool. So this is how our laser pen will look like. We will give some nice animation. And as always, if you have any questions, feel free to ask in the comment section, and you can also comment what other functionality you want to see in the app. And if you have not subscribed yet, please subscribe the channel, and thanks for watching.